let's get into this. Okay, get my other thing on here. So these are slides. Don't even worry about that. You know, again, this is part 3 of what we've been trying to do. What I want to try to cover today is most common issues and failures, Regeneration DEF issues, and if you haven't, it always will make a little more sense if you watch part 1 and part 2, you know, and you can use, you know, basically use that reference. By the way, someplace along the line, you're going to get handouts over here, or they should come online someplace so you can download the handouts. And of course, this will be recorded, so it'll be there forever, whenever you guys want, in case you got to drop out early, revisit it again. So, ironically, I was just doing the final touches to this PowerPoint this week. No, I think it was Monday. So I get this vehicle coming in, and that's the reason I call it Welcome to Our World. It just kind of fit in together. So if you see over there, hopefully I'll get my little thing going. This is a Ford, granted, you know, it's not a big Class 8 vehicle, but you still have what over here? You got the diesel, you got the DEF bottle here, okay? So basically, I put a title on, can you guess what this picture will lead to? Okay? I'll give you a couple guesses, and we'll go to the next one here, right? And of course, what you're seeing is we had that, not me. I didn't create the problem, the driver did. So basically what happened, you guessed it, one of your first guesses will probably be, you know, diesel into the DEF. Believe it or not, if that's what you said this time, you would be wrong. How often do you get somebody doing the reverse, putting the DEF into diesel? It's kind of a little bit touchy, because what happens is, just think about the DEF. This is diesel, this is a 6.7. Okay? So when the call came in, my son took the call, so we were talking about it. We told the guy caught it, of course. Thank God he didn't start the engine. So we told him, I said, you know, avoid even turning the key on this particular vehicle, okay? And the reason you don't want to turn that key on is because, you know, your low pressure pump, the minute you turn your key on, is going to do what? Exactly, it's going to try to fill it. So, I mean, do yourself a favor. I mean, get in a flatbed, you know, if it's in neutral, we'll roll it off, we'll roll it around the shop. But anyway, just think about, what is that area over here? Okay, what do if you went through the other parts, you know what we're talking about. You actually got what? You got purified water, 32.5% automotive grade urea, okay? And all you're trying to do is, it's a type of an engine for ammonia that you're going to need to reduce NOx in this. And if you've worked on diesels, I don't care if it's the smallest diesel in the world, the biggest diesel in the world, I think the first basic thing everybody's been taught is what? Water and a fuel, clean air systems. I mean, that is the weakness of all diesel engines. Has been that way forever and ever. So I just thought it was kind of funny to see that, you know. So oh yeah, I just see that Ryan, thank you again for coming on again. I've seen DEF into the diesel a number of times. Boy, I can tell, and it isn't cheap, you know. I mean, this one here, we had to actually, you know, drop everything, evacuate everything, and of course you want to clean up the tank, and boy, put something in there to kind of like, we use house and, you know, other chemicals. But the guy was very, very lucky. At least he caught it. So now, a little bit, not that I'm thinking of doing a OBD2 in one of my lunch and learns for heavy duty, because when it comes to OBD2, most of the time everybody's very, very, very comfortable with the car end of it, the light duty end of it. I mean, it's been preached into our heads forever and ever, you know, between the drive cycles and the monitors, and especially if you're in a state that does emissions inspections, okay? So, But basically, we got into the heavy duty end of it with the diesels, also with the OBD2, and it actually has helped us. Just think about that. If you go into your scan tool, if you got proprietary stuff, you know, if you're going to Cummins Insight or whatever, everybody get you. I have a J Pro, but I also have a Can Do. Even the J Pro sometimes doesn't get into everything, but however, there's pretty near none of the scan tools I ever ran across that at the minimum don't get into the OBD side on the heavy duty. And actually, if you think about it, pretty near everything that you've had to do on heavy duty, you know, since we got into emissions and everything else, that was the reason for OBD2. The manufacturers had to really follow their requirements to make sure that we have the input, the data, and everything else that, you know, to help us guys out. So anyway, with this one here, heavy duty OBD rule is approximately 124 required component system monitoring. Requirements is a proper word for it, okay? And of course, don't forget, like anything else that's constantly changing, not going with less, it's always going with more. Not to mention there's a comprehensive component monitor, just like you have with your light duty vehicle section, to capture each input, each output component. Each input sensor has 6 monitoring requirements. Each output actually has 4 monitoring. And of course, just like you have your light duty, you got your malfunction malfunction indicator lamp. And of course, that is a requirement, you know, to alert the operator of a malfunction, you know. And of course, the service interface provides a standard diagnostic tool connector be used to access hundreds of parameters, you know, and it's nice to get at the live data, drive cycle and all that stuff, historic data. But again, tool recommendation, you know, if you're going to work on this kind of stuff, good scan tool, do your research and network with others to see what will do the best job for you, okay? Not everybody is kind of the affordability, you know, different size of shops. Are you a big fleet? Are you multiple terminals? You know, it's again what you can afford, okay? And I see on there the Autel. I've been following that Autel. They've been really pushing that 906 and 908. You know, I'm going to try to do a little bit of more research on that one there, but good input. And that's what I want on the chat boxes, guys. This, you know, utilize this as a forum to really network with each other. Everybody, you know, because I don't know everything at all. I mean, I'm just a small shop over here, but I've been very fortunate to be into training for years and years and years, so. Using a scan tool, and of course that's why I put in there generically. So I picked an EGR issue, you know, and if you're, like I said, the people watching here, this Lunch and Learn, they're going to come from all over. You're going to have guys that have been doing it for years. You know, I know Ryan, you're so into it. To give you an example, Gino, you're so into it, you know, but you got to bear with it too, and I got to always remind myself, this might be the first exposure for some young person to get into the real world of what we're doing. So, you know, kind of forgive me sometimes when it looks a little bit kind of, you know, run-of-the-mill stuff, but it's hard to please everybody, you know, so. But anyway, establish communication, follow your scan tool instructions, establish, again, you're out there, you know what your scan tool does, what it can't do. But the rest of it is really, I mean, let's start with retrieve the trouble codes, you know. And again, depending on your scan tool, access the proper menu on the scan tool. And you might have something that's very specific just for EGR, you know. I mean, you got the bells and whistles for it. Of course, the big thing, next thing that you want to do is interpret the trouble codes, you know. And depending on your scan tool, you know, if you're on a laptop or whatever base you're into, there's a lot of memory in a lot of these scan tools and stuff. So utilize that if you have a lot of information there. Don't forget, you can go online. And I kind of put even Google, and once in a while I go to the Google. I work on so many different models of engines out there and vehicles that I don't always have access for everything. You know, if you have a fleet with nothing but Cumminses and Freightliners, I mean, you know, I'm sure you got everything related to that. And by the way, I'm not kidding. I do get calls, or we just had one, G sent me a message a few weeks ago. A guy was trying to get into, I can't remember what it was, but, you know, a vehicle that you don't hardly even have here, you know, so I recommended Can-Do, because Can-Do seems to have every foreign model that you can think of, you know, and I don't sell scan tools here, guys, just so you know. But next, monitor the live data, access live data menu and scan tool, look for any EGR related parameters, EGR flow rate, EGR valve position, exhaust gas temperature, intake manifold, okay? Now monitor your pick parameters in real time with engine running, and that means just today, if you open up your data that you can retrieve all the parameters, and of course I'm going to exaggerate, you're going to get thousands of parameters, but I'll tell you right now, if you're trying to do something with real world live data, minimize them so your data rate comes right at you. You don't want to be over there stepping on an accelerator pedal and you know, going boom, 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 but then you sit there for 2 minutes trying to get the data to catch up with you, okay? Sometimes God gave you the ears, you know, visual and everything else. Those are your greatest tools, and I like to see, if I step on the pedal, I want the response. I want something to fly at me right away. So that's another thing we sometimes forget. It's nice to look at everything, and don't forget your scan tool too. Most of them flip it over to graphics, whatever, recording and so on. Okay. So now compare the parameters, pick the specification, access the specs from your available sources, wherever you can get it from, okay? Because you want to know, are the values correct or not? Because that's the secret too. You don't want to, okay, what am I looking at? I don't have an idea. But boy, if you got something next to you that says, you know what, this value is not what's supposed to be there, and that'll get you even closer to finally figuring out what you're going on. And that's where we call compare the live data to specified values and ranges. Any parameter falling out of spec, considered to be a suspect, you know, possibly indicating a problem. Biggest thing that I can tell anybody, and I always do when it comes to diagnostics, know how the system is supposed to work. You don't want to go down a rabbit hole, okay? You want to know, can one issue cause another issue? And hopefully maybe some of the slides will kind of hit that area a little bit. And then of course you got the clearing codes. This can be optional. If clearing, will the light stay off? Will the light come on? You know, and don't forget, especially when it comes to emissions, some of this stuff you can clear and that light stays on, and it's like, what the hell, I didn't do, what did I do wrong? Okay, does it come on immediately? Do you have a run drive vehicle to meet certain conditions before the light comes on again? So again, clearing the codes will reset the vehicle readiness monitors. What about pending codes? What about counts on codes? Okay, so you know that Ryan, you're all right, buddy. You know, that's a very, very good point you're making there. When doing a force reach, and I'm going to hit that on the slides too, pay attention to the data. Don't just play on your phone. Thank you. DPF regeneration, generically again, you know, I mean, those of you that have to work on multiple different vehicles, you know you run into headaches, you're trying a reach-in, it ain't working your reach-in, you gotta go all over, why isn't it coming on, and so on. So generically, we'll take a quick look here. In a perfect world, and of course, you know, you guys that work on these vehicles, we don't seem to ever have a perfect world. Normal operation after treatment, TPF regeneration occurs while the vehicle is being driven. You know, passive or active. If while it's driving you don't have enough heat, a small amount of fuel is introduced into exhaust during reach-in. So again, in a perfect world, keep your hands off of it, driver dies down the road, conditions are right, yep, hey, let's put it in reach-in, you know, and you might see it when you go down the road, all of a sudden you see a little bit of smoke coming out of somebody's vehicle, chances are pretty good, you know, it's going a little bit of a reach-in. Sometimes, of course, the reach-in can be executed by a driver when the vehicle is parked and idling, okay? Call that stationary reach-in. By now, Well, I should take this back. By now, it should be considered routine operation. What I see in the shop, it really isn't. There needs to be a lot of education with the drivers and owners, and with these vehicles. Sometimes they still don't, after all these years, kind of have a good grasp on it. Now, however, OBD diagnostic monitoring system will often alert, and that was a nice thing with the OBD, okay? Often alert the vehicle operator of a malfunction requiring emissions repairs that can be as simple as a forced regen, okay? That a technician can perform better with a bidirectional scan tool. Sometimes the issue malfunction can wind up being more involved than just a simple regen. Because don't forget, these things need heat, they need to run. We have vocations out there, buses or whatever, stop, go, stop, go, stop, go, stop, go. Never get hot enough, never, so they need a little bit of an interaction, okay? How do we know a service required? Well, I should say it's not rocket science, but usually the after treatment icons on the instrument cluster will indicate some need requirements, such as after treatment regen. Don't forget, you have those HEST, the high exhaust temperature might come on, and of course, boy, I gotta tell you, all day long, after treatment DEF tank low level indicator. I shouldn't make fun, but how could you not know that your tank is getting low? But it's usually the education part on the other end, not us guys, okay? But I was gonna say I shouldn't make fun, because to be honest with you, I'm one of those. If I'm driving on the thruway or wherever and I'm trying to get some miles, and as if you guys don't do this, I watch my fuel gauge. It's like, when it barely moves, I think I can go another couple of miles or whatever. So just kidding, tell me you don't do that. Now, DPF regeneration, we're into it generically again. The after treatment regeneration required icon will typically flash when the DPF is full, requiring regeneration. And we're back to that high exhaust system temperature. It illuminates when a park regen is required, is initiated. Keep in mind, it also can indicate high exhaust temperature during a passive regen. So if that HEST, that high exhaust temperature icon is on, do not park or operate the vehicle near structures. Okay, they do get hot, just a little reminder. Okay? The after treatment DEF tank low level indicator icon basically illuminates when the fluid level is low. When the level becomes critically low, it will most likely start flashing. And of course, an MIL will indicate an onboard diagnostic fault. Lamp may remain active after repair until system confirms repair. And of course, when do you know somebody let it go to that point, guys? When do you know? When the vehicle comes in and a driver or the company says what? Anybody? Something's wrong. I seem to be losing my power, right? Question, does a forced regen fix every issue? Different issues need different solutions. For example, sensors can trigger fault codes. Regen doesn't fix those kind of issues. Cleaning or replacement might be required. It's even possible that a different component of the after-treatment system could be the cause of the perceived faults. Regenerations are meant to be an essential function to maintain the vehicle emissions reduction capabilities. Sometimes regeneration is required to correct an issue, of course. But again, I'm throwing out a lot of stuff here, guys, and here we go. Sometimes a forced regeneration is used to get a vehicle out of a limp mode long enough that didn't fix it, just to get you to your shop, and then somebody's got to figure it out, Yeah, I see another one here, stepping on accelerator. Once you interrupt, you do stuff like that because it automatically wants to go boost up the idle, and you start stepping on the brake or accelerator, it's gonna cancel it, very good, okay? And again, another good recommendation over here, I would recommend against shutting vehicle off, So thank you guys. You guys are experts out there. What the hell am I doing here, standing here? Just kidding. Yeah. So reviews, takeaways, if truck cannot, and that happens, cannot allow, I put / allow a regeneration, you know, depending how you want to look at it. Some of the reasons that might prevent a TPF regeneration could be, again, I mean, that filter could be so clogged. How about the turbo? Okay, variable geometric turbo operation, EGR faults. And there could be other reasons too, but my point being is, you know, if you're not going to get into a regen, you're going to have to look a little bit farther, okay? A little bit of note there, regen that cannot be started could lead to a D-rate and then to an engine shutdown, okay? So again, regeneration process to burn the soot accumulation inside the diesel particulate filter. It's just a little reminder from part 1 and so on. Okay? Generic regen failure list, engine fault codes, codes related to temperature, boost, pressure, VG, and other related to emissions. The thing with that, I see that debate between technicians. I'm curious what risk are. It's not necessarily a risk, but you're in the middle of trying to figure out what's going on in there. If you can't get into a regen, and I got a picture of, for example, like J-Pro does a real nice job over there, because don't forget who's doing the regen. Your computer's doing the regen. So once you start breaking in and stuff, you might have to kind of like restart the processes, and you know, it's like you trying to interrupt the doctor doing a trying to work on your heart, you know, I guess is the best way to look at it. But anyway, and that's a good debatable question, absolutely. So generic regen failure list, engine fault codes, codes related to temperature, pressure, boost, VGT, and others related to emissions. Just so you know, I'm trying to glance over at the chat box once in a while. I can't always do that, so I apologize, but you guys are doing a really great job communicating amongst yourselves. So the failed VGD causing TPF failures, not building enough heat. Because again, what do we need? Heat, right? Clogged TPF filter will not get the adequate temperature to properly burn off the soot. Everything's related to heat. Note, some of the symptoms of a clogged TPF are long and excessive regens. So if you get in a situation where it's like it's taking forever and ever and ever, try to keep that in mind. So if you suspect that, you need to monitor pressure temperatures during a forced regen to assure everything is working properly, everything is in range. And that's what Ryan had in the chat prior, quite a few chats up. I can't go over there and put it up again, but Ryan mentioned that, you know, that's one of the reasons you want to keep monitoring it. Don't forget you got the diesel oxidization cat too, okay? Revisit part 1 for typical locations. And you can also look at it as kind of a pre-TPF filter used to, it also helps to create heat necessary to start the TPF burn process, okay? And the DOC is the location many times for an inland temperature sensor. Generic regen failure again. Faulty temp sensors, any failed sensor, multiple sensors, it's going to stop the regen process. Critical input to the ECM determine how the TPF system is operating. Failed TPF pressure sensor, failed sensor will provide false readings. Possible cause excessive regens if it tells, for example, the ECM or the after treatment control module that the TPF is full. And this is an example when it's not. Okay, so there's a way of looking at, hey, can we have issues? What kind of issues can we have with the pressure sensors? Look, the sensor is used to measure the soot level before and after the TPF filter. Okay? And I'm going to try to zoom out here if possible. I hope I don't lose it. If you guys can see this a little bit better over here, and I'll probably get a slide, but I'm not sure what you guys have. Yeah, I'm watching us chats too, you know. You guys are in a really great politics here. That's I love it. I love it, the way you guys are going back and forth, you know, totally understand, no worries, blah, blah, blah. That's great. I don't know how many of you guys have J Pros. If you use a J Pro, just give me a little click here. Yes, I do. Yes, I do. But J Pro does a pretty good job over here, you know, that you can actually, and of course, I didn't record it, it's not live, but you can see the pressure differentials. You can click on the box, highlight and stuff, and they've always done a great job. If you look at the overall picture, you know, you can see all the different temperatures. So I just wanted to make sure that, you know, you can see, you know, again, dependent on your scan tool, dependent. So let me scoot this down. I guess I can't go to the next till I do that. Another continuation, EGR fault codes, and EGR codes will usually report the regen process. The EGR system is part of the after-treatment system. Not to mention a failed after-treatment hydrocarbon doser, that injector, you know, failed injector prevents the system increased temperature. You know, this injector is used to inject fuel into exhaust stream, increase temperature to start the TPF regen process. And this is just a suggestion. This might be, should probably one of the first things to check for a regen failure, you know. Now, exhaust gas temperature does matter. That EGT, exhaust gas temperature sensor, is used to measure exhaust gas temperature at different locations in the exhaust system. It's common to have 3 or more exhaust gas temperature sensors in the exhaust system. Purpose is to send real-time information to ECU to monitor exhaust gas temperature so the ECU can make adjustments ensuring proper engine emission systems. EGTs are used to protect various components from high temperature attained by turbocharger. Excessive temperature reported ECU will require the ECU, of course, to adjust the parameters, such as boost pressure, fuel delivery, necessary reduce or maintain operating temperatures. You know, and also they're used all over. Monitor particulate filter, determine the exact temperature for regeneration. Okay. So, 3 most common types you're going to run across is that negative temperature coefficient, and I went through that in that last part 2, I believe. I had a whole thing on some of this stuff. Positive temperature coefficient and digital thermocoupler. The NTC, PTC, different how they measure temperature, both provide analog information. Revisit part 2 if you can, and I had a whole thing on it. So now a DTC type of sensor, okay, converts analog signal to digital, because again, what do the computers love, right? Their language is what? Bits, bytes, on, off. That's their language, you know. They don't understand that analog stuff. So that's why you have the analog to digital converters in the computers. But regardless, faster response time, greater reliability, higher accuracy. Okay? Many illuminated check engine lights, unnecessary TPF regeneration, fuel efficiency complaints, and issues and other issues can be traced to EGTs. So keep that in mind. Okay. Now, generically again, so troubleshooting a TPF regeneration, if possible, and again, scan tool dependent. I don't know what everybody has. I see somebody just put in the Autel and when necessary, OEM software's inside and so on. And another one, mass airflow and so on. Troubleshooting TPF, if possible, try retrieving the following information. Codes logged, and are they related? History. The history is kind of huge, guys. Frequency, cleared fault codes. If you can get at the history, it's like, wow, seems like every other 5 minutes, just kidding, every other day maybe or whatever, you know, we're trying to clear codes and so on and so on. And don't forget today too, just like your cars, your newer vehicles, you got the permanent codes. You ever go in there, you clear the code and it still stays permanent, you know. So manufacturer's gonna got their algorithm to get rid of it, not you. But back to this again, regen frequency, how many hours since last regen? What is the repair history? Has the TPF been cleaned, or how many hours since last cleaning? Is the engine using oil or coolant? Boy, that's huge. You know, again, we don't live in a perfect world. Has the EGR system been checked? Plugged EGR ports. A little bit of a tip here. Restricted air filters, plugged EGR ports, boost leaks. They're going to generate codes that can be related to regen issues. Knowing prior codes can help in finding the root causes. You know, all day long, and I'm sure you guys have heard that over and over and over and over again. Basics, guys. Go back to the basics. Start with the basics. You know, try to avoid making it rocket science and go down into rabbit holes, you know. Clearing the faults, things to know before clearing, conditions, what set the codes in the first place. You know, conditions for running the diagnostic monitors. Actually, I'm going to get into that in a little bit. So actions taken when fault code is activated. What conditions must be met for clearing fault codes? Another important concept. Resets may not clear the MIL lamp. And I know you guys have run into that. Resets might not eliminate the D-rate. Conditions for clearing the fault code and D-rate might not have been met because the conditions for running the diagnostics trips have not been met. OBD. How many times have we ran across clearing the fault codes only find the MIL lamp still stays on and D-rate is still active? And then of course you pull out here, you know, like me, I'll put a picture on, and of course you guys notice, right? Not too much to pull out, guys. So that's all right, you know. With this hot weather in the sun, I'm one of those, I gotta wear a hat. My wife always reminds me, get your freaking hat on, you know. So, but anyway, after treatment TPF regen analyzer test. Somebody mentioned go on the OEM Cummins and everything, auto when necessary, OEM software inside and so on. Okay? And this is just plucked out of there. There is such a thing as a TPF regen analyzer test. Require Cummins inside electronic software used when directed by published troubleshoot. You follow the tree. Test takes approximately 30-60 minutes. Used to identify malfunction engine performance components. Okay, what type? Engine testing, crankcase, and of course we're into what? The after treatment diesel particulate filter regen test and so on. Okay, test status will be shown in a status window. There's also test description window, test instruction window. Okay, just a little continuation. I'm not going to stay. We do not have time to go through the whole process here, but this example of a failed test. EGR differential pressure is above specs. It's going to tell you perform the following. Clean and inspect the EGR valve. Clean and inspect the EGR differential pressure sensors. Check the EGR differential pressure sensor reading with key on and engine off. If you got a differential pressure sensor is, you know, 0 plus 2, you know, 0.3 psi, replace the sensor. And the reason I'm not trying to hesitate here, but I was going to throw in there also, once you get used to certain engines, once you get used to what to look for, I'm sure a lot of you, okay, jump right into those areas. You know, you're automatically, it's like, you know what, I've had such a, you know, every time I turn around, you know, I got some EGR blockage. So what can temperature readings indicate? Now we're talking about the DOC. Suspect a failed DOC if outlet temperature is lower, TPF outlet temperature. This is definitely just generic here, guys. I will tell you right now. Look at it kind of generically, okay? This means the DOC is not burning a soot load effectively. DP is doing more of the burn. You know, just think about these concepts here. There's an acceptable temperature variation. Now, this part, like with the 110 and everything, I did get out of international because I tried to look at everybody's a little bit. So I can't just throw everybody's variations and stuff here. So just so you know, that was from international. So note there's acceptable temperature variation, 120 degrees Fahrenheit plus minus due to soot-loaded TPFs burning hotter than a cleaner new DPF. Also, high idle times on running light load can store unburned fuel. And again, high idle, think about vocations, the buses and garbage trucks and, you know, stuff like that, causing higher regeneration temps than normal. In summary, look, the TPF outlet temperature, higher DOC should be a cause for diagnosing. So all I'm saying is, if you're the type of guys you want to rely a little bit on taking some temperature readings, you know, I'm looking at that as giving you just a little bit of a guideline here. Okay? Now, when you do temperature readings, one of the things you want to be aware, I just cut this, I believe, a month or two ago, ago. I think it was for the other part. I never got to it. I cut this unit apart. The only reason I cut it apart was that you need to be aware of internally that you don't see. There's insulation wrapped around these catalysts, okay? But there's areas where you don't have any insulation. And if you're over to take your pyrometer or whatever imaging camera, you got to be careful that, or at least realize you have areas like that in there, okay? Now, I did take this from international. This is just a guideline, guys. Don't totally hang your head on, but it's just giving you an idea, because the previous slide I tried to show you about the thickness of insulation, and of course, just look at this chart. You got it in your handouts, and it'll tell you some of the differences, you know. Now, the integrated after-treatment hydrocarbon dosing injector module. It's one for Volvo Mac over here. Typically located between fuel system assembly, used to inject extra fuel. I did discuss that, I believe, either part 1 or part 2. Okay. Note, active regeneration occurs when temperature during normal engine operation is insufficient to ignite the soot particles. Again, that's what we're trying to do. So if you get a reaction between the fuel and precious metals and DOC, that's going to increase the temperature of exhaust, and it's going to cause the soot particles in DOC and TPF to oxidize. So this is kind of refreshing what we did the other week. But however, okay, I wanted to take it a little bit further, you know, and I call it a relationship. This system is made of 3 primary components. You got the module, AHI module. You got, of course, your fuel and air lines. And you got the some injector nozzles. Some people call it or refer to it as 7th injector. Now, this is where I'm getting at. You know, you got the fuel and air lines. There are 3 primary failures with this module. Contaminated air. And a lot of times, guys don't put 2 and together. Your air system that you have in your system, yes, it can affect that module also. And this is that relationship, you know, do you drain your tanks, you know, you take care of your air dryer, your fuel. I mean, this is using your same fuel that the engine is, fuel filter, PM, you know, and we can go very deep with electrical faults there, you know. And point being is, could this system affect the engine? Absolutely. You know, what if you have fuel leaks, fittings, and so on and so on? Difficult to start, and lines, fittings, kinked lines. So just keep that in mind. That's all. The system quite often calls for failed regeneration, constant request. Okay, and again, why? What's the requirement? Heat, 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 heat. So if the nozzle is clogged, plug. It's not going to inject enough sufficient fuel. You know. And of course, don't forget, it's just not shooting something out properly atomized. Right? What is a D-rate? So let's do a real quick review. D-rate, designed to protect the engine or after-treatment system from damage. Okay? Program inside the ECM limits either the power vehicle speed, and you guys have run across that, you know, all the time, and I see that make sure to use coalescing air dryer cartridge for those Volvo Mac HEI. Very good, Ryan. Thank you again. Okay. Number 1 cause of D-rate seems to be the SCR DEF system not operating properly. Following are some of the components control D-rate. Because we're switching over to SCR, the DEF fluid, of course, the quality level. Okay. Oh, gee, I didn't notice that. That's what that gauge was for. Can put you in a D-rate. The DEF pump assembly pumps the DEF fluid through the system. Pump failure, of course. Doser valve regulates DEF fluid injection. Failure will result in a D-rate. And of course, don't forget, something is taking readings over there. You know, how much should I put in there, and so much and so on. If those NOx sensors fail, you're also going to have problem. Okay? So this one here is, I just plucked some stuff, you know. When I get stuff into my shop, I'm always looking for something that eventually I'll use. I got like thousands of pictures, hundreds of videos, so real fast I just pulled some stuff out. So here it is, suspecting DEF issues creating a D-rate and so on. Okay? The big question, this is a fuso, can your scan tool do a good enough job verifying performed bidirectional testing? And sometimes the bidirectional is huge. So let's see what we got here. Okay? Now this one I did use a can do. I can go bidirectionally, low dosing, intermediate dosing, high dosing, and this wound up being nice. And I'm gonna click on it. Okay.
Okay, she's a medium.
So basically, why I'm not getting sound? Oh, basically we're going through the low, the medium. Okay, it is squirting, but however, and it's going to go through the high section. I don't know why I'm not hearing that. Hopefully you guys can hear the sound.
Okay.
Maybe not, so I'll interpret. But anyway, that's what that's about. So, you know, now of course, you know, we're going to take a look inside too. You know, if we're having that kind of issues, I'm going to get my borescope, you know, a little bit of a, you know, digital borescope, and we're going to go in there. We're going to do a little, and I'm doing this fast, guys, okay, because I'm not just going to walk away and replace the doser. You know, chances are pretty good we're going to have other issues. Okay? So here we go. How long has this been going on, right? Looking up. Never mind, I'm not going there, but looking up the pipe over there. So this had multiple problems too, by the way, just so you know. You can see on this, the clamps are very, the bolts themselves, they've been on forever, but look how they're splitting open over here. Wonder how many times, if anybody's been complaining, or I don't get it, but I guess I'm no different than you guys. You guys probably have seen everything out there, you know, what I see and so on, and sometimes you kind of shake your head, you know, why didn't anybody catch these, you know, so, you know, and of course, just a shot on the inside, you know, same thing. Of course, you got things going wrong, you got a damage here. This is from another vehicle failed system. So again, you talk about blockage, you know, gee, why did I go into D-rate? I don't understand this, you know. So, but anyway, do me a favor, Bobby, let me switch the camera just for a second, okay? If you can zoom in here, okay, and all day long. You might get something coming out of here, okay? But boy, if it doesn't come out in a nice little spray, you know, evenly around, okay? So you'll have problems. All right, that's enough. I don't want to be seen. Go back to this. This is a Freightliner with a Detroit engine, okay? And I went and, boy, I'm gonna try to zoom in. Anyway, real fast, another little selective catalyst, closed loop control. This is from the J Pro, okay? So I'll walk through this real fast. Like I said, we got a lot of, I'm trying to do a lot of stuff here where you guys get a little mad if I go a little over. But all this shows is like, hey, I'm just trying to get comfortable with components, you know, nothing exotic. This is a good sign. You get on a vehicle, you know, you don't have the fairings and everything in there. Lots of room, okay? And of course, we all know everything's going to come apart easily, right, guys? It's always our little hope, you know. You kind of make that prayer to the mechanic God, you know. So DEF lines going, they tend to be blue lines, you know. So stuff you can follow from the tank right to the unit, but I'm going to jump through a lot of stuff, and there's my dosing unit. Like I said, you know, one of those is like really nice to get at, you know. And of course, the next thing is, you know, you go in there with your socket, and of course you do pray to your mechanic God again. It's like, hopefully everything comes apart, nothing snaps, and wow, that's a good feeling, isn't it? Always, yeah. And of course, to research again, look inside. But now, I'm probably doing it a little bit backwards here, you know, but that's okay. So what this is going through, if you look over here, connect JPro to your tube, blah, 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 blah. Then it's going to go yes, no, everything else. And I'm going to get you in the next slide. And hopefully in your handouts, ooh, I screwed up here. Damn it. Okay. And hopefully it says over here. Come on. Basically says determine DEF percentage using a refractometer, and that's the point I was trying to get at over here. You know, so you follow the prompts, because you guys know. Okay. Then again, just another snapshot showing, you know, with a J Pro, it's very nice. You see the DEF tank and everything else. But look, if you don't have a refractometer, get yourself one. Because so often, you have no control who put what in, when they put it in. Has that stuff been sitting on the shelf? And these computers today are so sophisticated, okay, that they can actually catch a lot of the stuff. That's all I'm trying to say with this thing, you know. So now, another issue, okay, after treatment exhaust fluid and so on. We talked about the counts and everything. You know, my thing here is, where do we go from here? Okay, we look for things that are common. So I just picked one little area here. Fault code 1679 occurs when a DEF tank temperature sensor indicates a tank temperature that is too high, too low for the ambient conditions. Chances are pretty good there will be a reduced engine performance. The following is critical information you need for this fault code. Okay, so let's go back to one of my first slides we had here. We had the slides about the OBD, and I told you maybe we should do, you know, if you guys are interested, a whole thing and revisit OBD. Okay, because in that OBD, they really spell out some of the requirements and everything else, and this is a perfect example. So now, component location. If you've got a hardwired, the DEF tank temp sensor is in a DEF tank. Nice to know, right? And again, OEM dependent, you know. For multiplex, the DEF sensor is part of the dosing unit. So we got a couple of choices in here. However, this part right here, condition for running the diagnostics. Okay? The engine must be turned off for a period of 8 hours before the diagnostic runs. What do we call this? We call it a cold soak. Where else, if you guys work on light vehicles, have you guys run across that? You can type it in there, because I'll keep on going. Conditions for setting the fault code. The ECM detects when the DEF tank temperature sensor reading is higher or lower than the other temperature sensor on the engine. Continued. Action taken when the fault is active. The ECM turns on the ambient check engine light and the MIL immediately when the diagnostic fails. What? OBD, right? 2 consecutive trips. Conditions for clearing. Validate the repair, of course. Okay, engine shut off, key off for 8 hours. After the 8-hour cold soak, okay, start the engine, let it idle for 1 minute. The fault code status displayed on service tool will change to inactive immediately after diagnostic runs. ECM turns off the amber check engine lamp after so on and so on. For OBD engines, the ECM turns off the MIL after 3 consecutive trips where the diagnostic runs and passes. And I often said, it's like, sometimes I do prefer let that ECM turn it off, because if that ECM turns it off, I got to tell you all day long, I'm very confident that I did my job correctly. The computer saw it. It's like, hey, sweet, not bad. You fixed this thing. Go home, rest, go on vacation. Just kidding, take some time off. Okay? And of course, dive service tools can command to reset all, you know. Highlights for checking temperature sensor: key on, engine off, connect the service tool, check the accuracy of the DEF tank temperature by measuring the temperature of the DEF in the tank with an infrared temp probe. Hey, temperature, right? Whatever means you can get at it. Compare that temperature to the parameter monitor on your service tool. Is the temperature, you know, within those measured values? If it is, next step would be checking the DEF temperature sensor connector pins. If not, replace the DEF temperature sensor. And again, I'm keeping it kind of simple. I didn't go through the whole flow here, okay? If you're lucky, that's as simple as it gets. If not, you guys know, I'm preaching to the choir, okay? You're gonna have to go further, aren't you, okay? For example, check the circuit response, disconnect the sensor. You're gonna watch it on your scan tool. What's the response and so on, okay? Various steps will require you to check for open, shorts, and high resistances. Some examples: key off, engine off, disconnect the temp sensor from controller harness, service tool connected, key on, engine off, place a jumper wire between the DEF temperature sensor signal pin, return pin, okay? Wait 30 seconds. If there's response, replace the sensor. If not, check ECM and OEM harness connector pins. There's still an issue. Next step would be checking for open circuit, you know, in the OEM harness, because don't forget, you know, you're talking between the actual engine guy and who depends on who put that after treatment in there. Is it the OEM and so on? Okay, but the bottom line, whatever you do, all of these will definitely require electrical fundamentals and meter usage knowledge, guys. Okay. And again, with that temperature sensor, I'm pretty sure it was in part 2 that I did put some slides in on how to, you know, how to look for issues with those sensors, what type they are, and, you know, how to best diagnose those particular sensors. You know, this is highly, highly unusual. You saw the box with the questions. This is highly unusual. I think this will be the first time I've kind of finished the slides. You know, Ryan, don't bust my, you know what, you know, are you done early? You know, so it's just, but I love those. Well, I'll say it anyway, ball busting, it's okay, you know. It's like, it didn't hurt, Ryan, by the way, just so you know. Yeah, I'm kind of done early. I mean, you know, you know, you guys start to complain. You know, you guys sent those little messages to Dorman. Can't this guy shut up? You know, he keeps us going over and everything else. No, just kidding, guys. You know, I just want to tell you, it's been a real nice ride doing this too. You know, I really enjoyed Lunch and Learns, and again, I got to apologize if I can't always watch the chats, but I do, believe it or not, I like the real good remarks and everything else. You know, I am gonna keep this going. I'm gonna, I don't know what I'm gonna do next month. Like I said, I might think about do the OBD. Let's revisit, go back to the basics a little bit. You know, our little helper OBD too. You know, but also. G just asked me the other day, you know, when we were doing the AC course, he asked me, would I be interested in maybe doing some 2-hour webinars with heavy duty stuff? And I'll be honest with you, sometimes we're trying to do so much over here, you know, 1 hour might not be enough. So we're thinking of, I could possibly start out doing like for example, get back to maybe ABS or something, but actually do a real good job when you do it with 2 hours, you know. And at the same time too, guys, again, heavy duty AC, we're shooting for August, I believe I said, we'll get the flyer out 27th, 28th. And if you guys want to travel, or if you're in our area here, you know, it's not the fanciest classroom, but we have a real good time here. And the lunch is always great. I think everybody comes here just for the lunch. So I'm going to put one last slide on here. Let me get over here. Here's your QR code. Do me a favor, take a little snapshot or whatever it is, you guys, and send. Take the time to send a survey in. You know, if you like it. If you didn't, should we make changes? And you know what? Maybe at the same time, you know, I'm not sure what that survey looks like, but if you want to see anything different or something happening, knock yourselves out. So thank you again, guys. And if you got a minute, I'm asking Doreen just to keep it on so I can see as the chat goes up and down a little bit. You know, Greg, thank you. Well, no, thank you for the comments. Rick, this was great, beautiful. Just so you guys know, that's the kind of shit, I didn't say the bad word, keeps me going, you know, keeps me pumped up. So I know you guys got to get going, so thank you again. And somebody says email Doreen, maybe you can email to that person that cannot get the QR code. Okay. Wisconsin, you know, I love it, guys coming from all over. Again, I mean it truly. I hope the weather is treating you guys halfway decent out there, you know, and keep the faith.
Sweet, thank you again, and thanks everyone for coming out. And we do want to remind everyone, Swede and I will be doing another heavy-duty AC class up in his place, Latawaka, August 27th and 28th. Get a max certification, get a great book, real hands-on stuff, covers all the AC refrigerants. Come out and check it out.
Oh,
thanks again, Swede.
Yeah, don't shut it off. You just reminded me something. G and I were also talking. If you guys are ever interested in doing like a 2-day brake course over here, holler. We can put that together too. And just so you know, I do travel with the brake course. You know, I take my brake boards and everything, as long as I'm not going up into Alaska or someplace. But we can arrange a lot of that stuff. Whatever you guys want, we're yours. You know, Dorman is there to whatever you guys want. Thank you.